Well, thank you, and thank you for staying to the bitter end. I realise I'm between you and the drinks reception, so I'll try to keep the time. What I'm going to try to do over the next 20 minutes is really just tell you a personal story about my time in Africa and how somebody like myself, who is effectively a non-clinical academic, and I spent my life sat at my desk in Addenbrooke's, generally saying silly things about viruses that cause gastroenteritis, how I went from this position to spending approximately 5 months over the last year in Sierra Leone working in an Ebola treatment center. Most of it spent in this tent with no windows and lots of insects, performing various aspects of the Ebola response. Now, I was going to show you a video, but I don't think this works. No, but instead I will describe what this shows. This video was really just to illustrate what the situation was like on the ground during the early part of the epidemic, and it was a video, the person being shown, Dr. Brett Adamson, works for MSF, and despite repeated calls by MSF for international help, the response was too late, and this is effectively footage of him saying how overwhelmed they were and how the treatment centers they were building in Liberia simply weren't big enough to maintain capacity and support for the number of people who were being tested positive. Now, this is an epidemiological breakdown of the epidemic as it currently stands. You can see approximately 28,000 suspected or confirmed cases and approximately 11,000 deaths. During the early phase of the epidemic, as a virologist, we keep an eye on anything virological in the news, and it became very clear to me that this epidemic was not going to go away. This it wasn't like any other Ebola virus epidemic we'd seen before. And in August 2014, in very close discussions with my wife, I made a decision that it would be right of me to step forward as a volunteer and try to find a way of me providing support to the epidemic. Sadly, as a non-clinical academic, that pathway for me going from Cambridge to Sierra Leone to work in the treatment centre was not clear. It was very difficult. In fact, it took about a month of me phoning around to find a path where I could actually provide help. And what I felt was that there was a clear diagnostic bottleneck. So one of the biggest problems in the outbreak was there was a significant lack of laboratory support. So in the early phases of the epidemic, it was taking approximately 2 to anything up to 10 days from a patient turning up with possible symptoms to then being tested as either positive or negative. And this really contributed to the expansion of the epidemic, and diagnostics was something I felt that I could help with. I was eventually deployed. It took some months, and this reflects really the delays in the deployment. The UK government deployed a number of us, and I was being deployed as part of a Public Health England team into Makeni in the northern districts of Sierra Leone. All in all, I've been in Sierra Leone approximately 5 months, 5 different deployments. The first 2 initially were to establish one of the first diagnostic facilities in the northern districts. The second deployment was to maintain that facility, and then subsequently I established a sequencing facility within Sierra Leone to provide support to the epidemic. And I'll just talk you through the various processes. As I said, I was being deployed as a team leader to work in a DFID-funded Ebola treatment center in Makeni. So this is Makeni in Sierra Leone in the northern district. It's a beautiful place. If you ever get the opportunity to visit, please do. This was the plan of the treatment center that was presented to us by DFID. It's split into 3 sections. It's quite a large treatment center with up to 100 beds. This is the red zone where the patients stay. This is the green zone where the clinical staff and the laboratory is, in fact, located. And this is the white zone, which includes the canteen and administrative offices. This was the plan. When we turned up, what I'll just say very briefly is that the situation on the ground in Makeni at that time was very, very bleak. And I don't want to go through this in any great detail, but this is an article that was published by the New York Times that describes the current situation in Makeni, in the regional hospital in Makeni. And you can see from these pictures how children and adults were turning up to hospital and effectively being left to die on the floor in these hospitals. So the healthcare systems were completely overwhelmed and the situation was pretty desperate. So we turned up into Makeni. This was what we found. The treatment centre wasn't completed. The laboratory, the outside of the lab had been built, but in fact the rest of the treatment centre itself was effectively just a large, rather dangerous building site. At this point, a decision was made to try and open the laboratory as fast as possible because there was no laboratory support in that district, and the samples were all being shipped down to Bow, down to the CDC lab in Bow for testing. So the aim was to open this laboratory as fast as possible to provide diagnostic support. This is the team. This is me and the rest of the team. You can see we look like typical lab scientists. We do not look like builders. We do not look like manual laborers. The first week was basically spent maneuvering tons and tons of boxes. We had 3 of these trucks turn up and several of these with heavy equipment, all of which we had to unload ourselves in 35-degree heat with 100% humidity. And the team did really well. In fact, we all recognized that, this was important and we had to just get on with it. And the inevitable series of injuries, but everybody survived. Again, the next few days were effectively spent trying to build a laboratory, trying to find all the equipment, put it all together, make sure it worked, and get the workflow operational. And this slowed us down significantly. So logistics was a huge problem back at the start of the epidemic. Materials would turn up and they didn't work, they didn't fit together, the power would go off, the freezer everything would defrost. And in fact, some items just simply didn't turn up. And in those cases, we had to basically make things. This is us trying to make something for inside one of the isolators. So we go to the local market, find things that we think might do the same job, stitch them together, and see if they worked. The end result was that the lab opened on the 13th of December. This is much later than we'd actually hoped. But the biggest problem we had was that we needed to be confident we could operate the workflow and sustain it, and we could do so under safe conditions. This is the lab as it currently looks. This is Tim Brooks, who's the head of Public Health England in Sierra Leone. He came along and ceremoniously opened our laboratory. And in fact, the lab is still operational. And Public Health England continue to send teams out, and they will do for a while. In fact, Public Health England plan to be in Sierra Leone for a number of years beyond the epidemic. This is a typical workflow of the samples that would come in for diagnostics. At the start of the epidemic, we primarily get blood and swabs. Later on, we've been getting more exotic samples like breast milk and semen samples as the needs arise. The samples would come to us via courier. They'd be processed by somebody like this. This is, in fact, me in my lovely orange Crocs. They would go into a flexible film isolator, which enables us to work with the samples under containment without any risk of exposure. And an aliquot of the sample is taken and the virus effectively inactivated. So all the infectivity of the virus is removed in the flexible film isolator. Before the samples are taken out, the nucleic acid extracted and a diagnostic test which looks for the presence of the Ebola virus genome run. The lab has tested approximately 15,000 samples the last time I was there, probably more now. And Public Health England have 3 of these laboratories operational in country, or had at the height of the epidemic. And as I said, this laboratory is still functional. We faced numerous challenges back at the early stages of setting up this laboratory. A lot of that was based around logistics, and actually it was just us adjusting to the environment, the heat and the humidity and the food. But I'd say the biggest challenge we all faced was, in fact, the reality of the situation we were in. Even though we didn't have face-to-face contact with the patients, because of the location of the laboratory and because of the way the patients move from stage to stage through the treatment center, you were witnessing these events on a daily basis. And I'm a father myself. I have 2 young children, and some of the hardest sights you would see is, in fact, these small kids come in on their own. So these are survivors who played a very vital role in the care of these younger children. You would see them be tested positive or negative, and then you could either, in many cases, see them progress through the treatment center, and sadly, in many cases, pass away. Now, despite what was happening in the treatment center, And this may sound a little strange, but actually working there was a very pleasant experience. The treatment center itself, the atmosphere there was one of positivity. There was music playing. Everybody was there for a common cause. And at the height of the epidemic, we had, I'd say, almost 200 members of staff working in various roles in the treatment center. And there was just an overwhelming sense of positivity. And in fact, many people did survive. This was going to be a video of this guy dancing very badly. Unfortunately, it doesn't work. But every time a survivor would be released from the treatment center, there was a very joyous occasion, lots of singing, lots of dancing. And this really did lift the spirits for everybody who worked there. Now, in my first deployment in December 2014, once we'd established the workflow and the laboratory was operational, we started to think about other things we could do. And I identified quite early on that there was a real need for in-country genetic sequencing capabilities. Because at that time, we knew very little about how this level of repeated human-to-human transmission was affecting the virus. And there was very little sequence data available for the viruses. And in fact, the sequence data that was there was being released in a time frame that made it largely useless to the people who were on the ground. And samples were being taken out of the affected countries, sequenced in the US or in Europe. That data prepared for publication, and the publication being released. So it was typically between 4 to 6 months from a sample being taken to the data being available to the people who really needed to see it on the ground. So we made the decision, somewhat naively, that why don't we just bring a sequencer to Sierra Leone? How hard can it be? Well, it turned out it was difficult, but we did actually achieve it. The aim was to use it to identify and confirm epidemiological links when patients present with no known source of infection. By sequencing their virus and having a good database of viruses from the circulating population, you can link that patient into a chain of transmission. You can understand virus evolution to make sure the virus is not evolving faster than one might expect. And again, importantly, during probably in January of 2015, there were 15 or more laboratories operating in Sierra Leone, all using slightly different tests, all targeting different parts of the viral genome. And at that point, we didn't really know whether this repeated human-to-human transmission was compromising our ability to detect the virus. And lastly, the sort of longer-term aim was really to try to provide Sierra Leonean scientists with access to this sort of technology. This technology doesn't exist in Sierra Leone, and we felt that in the longer term we could use this. So I landed at home on the 23rd of December, and I spent my Christmas period phoning suppliers and trying to put together a grant application. Thankfully, some suppliers and sales rep work over Christmas and Boxing Day. And we were awarded a research grant from the Wellcome Trust. That award was made in February. And then in April to May, this was actually my third deployment, the aim was to take the sequencer out and establish a sequencing facility in this storage tent, which was approximately just next door to the diagnostic facility. This was later than we'd hoped. And the reason this was later than we'd hoped was because none of the companies we approached would provide us with in-country technical support. I've never operated a sequencer, neither has anybody else in my lab, so we had to go and train how to run this thing, how to fix it, how to install it, and so this slowed us down significantly. Thankfully, the truck turned up on a Wednesday afternoon. This is it turned up. I've never been so delighted to see a heavy goods vehicle in my life. This would have been a video showing us putting it together, but it doesn't work. But suffice to say, everything made it there thanks to DFID. They played a very important role in shipping our stuff largely free of charge, making sure where it left Cambridge, it arrived intact in Sierra Leone. And the end result was, in fact, this. This is our sequencing tent. We have PCR hoods, which enable us to work with the viral nucleic acids and keep the dust out and the insects out. We have a liquid handling robot to enable us to process the final stage of the sequencing. And we have our sequencer, shown here. For those of you who are familiar with sequencers, they'll recognize this as relatively old technology. This is not the most cutting-edge sequencer. And we selected this one for several reasons, one of which I can't tell you because it relates to the ethics of the company that we tried to buy it from, but I'll save that for later. But effectively, what we needed was a machine that we could be confident would work in this environment. This is very hot in this tent, even though we have air conditioning, it gets to 30, 35 degrees, very humid, insects and dusts. And a lot of the technology that's available simply won't work in this environment. This does, and this did work, and this was in hindsight, one of our best decisions. So what have we done? Well, so far, we've processed in excess of 1,200 clinical samples for sequencing. There are no other samples in Sierra Leone that we can get access to that will sequence, so everything that's available to us has been processed. This has resulted, I think, closer to 700 full genomes now being produced for Ebola virus. This is the largest single data set produced by any lab. The vast majority of these were made immediately available to anybody who wanted them, so we let the data make the data freely available. And in fact, we have our turnaround time down to as short as 24 hours. So from a sample arriving in our laboratory to have a full genome of the virus ready for the epidemiologist to analyze and interpret is approximately 24 hours when it works well. We're also heavily now embedded into, and have been for many months, the official title is the Ebola Outbreak Sequencing Support. We're embedded into the response, and by working with the Ministry, WHO and Public Health England, we have a workflow that enables us to get the samples when they're identified, generate a report, interpret that report, and provide it in such a way that it's meaningful to the people who are on the ground. We've used this for a number of things. I don't have a lot of time to go through all the data, but just to highlight a few things that this was useful for. This is a time-resolved phylogenetic tree, and effectively this is a timeline, and these red dots are some of the viruses that we sequenced. Each of these sort of long branches represents either a transmission chain or a lineage of virus. And by doing this sort of real-time sequencing, we could identify when transmission chains and interventions had worked. We could also place individuals who presented with reporting no potential source into one of these transmission chains. And the data, which is not visible on here, at one point in the epidemic, we had clear evidence of cross-border activity. We were detecting viruses from Guinea in Sierra Leone, and by sharing the data, we were able to say that Sierra Leonean viruses were being found in Guinea, and this was because the porous nature of the borders. We informed the Ministry of Health, and of course, eventually this sort of cross-border activity has stopped, and we didn't see much of it later on. We've also been involved in a number of case studies, some of which I can't talk to you about, but this is some interesting, just two examples. This one is what we would refer to as a cryptic transmission event. So there was a house in a village in one of the districts that was under quarantine due to an Ebola virus-related death. The quarantine period is 21 days, and it's 21 days because this is the longest incubation period that's ever been recorded for Ebola virus. In fact, it's longer than that. 25 days post so day 25, a 13-month-old baby dies in this household and tests positive for Ebola virus. The child's mother, who's breastfeeding, has never showed any symptoms. So there were a number of really important questions that were raised by the outbreak response team on the ground. The first was, what is the source? Where has this child got this infection from? Is there somebody in the community who is not reporting their illness? But more importantly, there was real concern about the fact that this came up 25 days post-quarantine. This would be a hallmark of the incubation period of the virus getting longer, and this would have really significant implications for the outbreak response. We were able to get samples of the mother's breast milk and the mother's blood. Her blood tested negative for virus, for viral genome. Her breast milk tested positive. We were able to sequence we also were able to do serology. We did this in Sierra Leone as well. The mother was seropositive, indicating that she had been infected and at least generated IgM antibodies. And in fact, we were able to generate a full genome sequence from the virus from breast milk and one from the baby's swab, and we were able to show that these viruses were effectively identical. So the conclusion from this is that this was evidence of transmission via breast milk following atypical EVD presentation. Note, this is not asymptomatic presentation, and the word asymptomatic, of course, comes with a lot of, this is a very sensitive area. This is atypical presentation. The presence of the sequencer, having the ability to do this sequencing in real time in Sierra Leone, has been really important for the end game of the epidemic. And this is the last case of Ebola virus that's been detected in Sierra Leone. And it's important because it enables you to identify place these orphan cases with no known source of infection into a known chain of transmission. So this was a 16-year-old girl from a village that was close to Makeni. The village hadn't had a case of Ebola virus since December. So at this time, it was 9 months. The district hadn't had a case of Ebola virus for 3 to 4 months. She presented ill on the 7th, was transferred to our treatment center on the 12th, and subsequently died. We were able to take multiple samples from her and sequence them, and what we found, in fact, the closest match to her virus was one isolated from the same village, but back in November and December of 2014, which is somewhat puzzling, but when you now realize that many survivors can maintain virus within their bodies in various places for some time, up to 9 months, the conclusion drawn from this was that this wasn't a new introduction. This was, in fact, a transmission event, an unknown mode of transmission, but from a survivor to this young lady. So at this point, near the end of the epidemic, we reached the point where we had to decide what to do with all this equipment and all this resources. So we've spent all this money and all my time getting all this stuff into a tent in Sierra Leone. Well, what do you do with it when the epidemic finishes? So we thought about post-Ebola capacity building. What can we do? The lack of laboratory support and expertise in Sierra Leone was a major contributory factor to the explosion of the epidemic, and it really led to a real over-reliance on international support. Whilst the Ebola virus, this outbreak has been terrible, in terms of disease burden across West Africa and in Sierra Leone alone, this is just one of many viruses and many pathogens that are in that environment that are causing significant numbers of deaths and illnesses. I heard a rather scary statistic the other day from a presentation from Miriam to Educate to say that 1 in 3 children in Sierra Leone are dying before the age of 5. And this is partly as a result of the effect of the Ebola virus epidemic on healthcare. Many of these children are dying of infectious diseases, and the vast majority of times we don't know what those infectious diseases are. And in the laboratories alone, in the one laboratory in Makeni, we would typically receive up to 70 to 80 swabs per day from people who have died in the surrounding districts. And in many cases, these looked like classical signs of infectious diseases. They all tested negative for Ebola virus. We have no idea what is causing these deaths. So there's an urgent need for capacity building in the area of laboratory sciences in Sierra Leone. And with that in mind, what we did, and as of this middle of September, was we worked with the local university. This is the University of Makeni, and we've established an infectious disease research laboratory with them. This is the lab here. In fact, this is a house owned by the president of Sierra Leone. This is his home village. And we've moved all our equipment here, and with the help of other suppliers, we've purchased other accessory equipment, shipped it all out, and now we have what looks to be, it's probably better than my lab in Cambridge, if I'm being honest, in terms of space and condition. So we have, it's quite a large building. We have a Containment 1 molecular lab, which actually has much more benching and equipment in it now, which we suspect could easily hold 15 to 20 people. We have 2 containment level 2 facilities with either class 2 or class 1 containment hoods we shipped out, some of which survived the shipping, not all of them. And we have a bunch of other accessory equipment, so multiple -80 freezers, PCR machines, real-time PCR machines, all the things you would need to do some basic molecular biology and infectious disease characterization. We've also facilitated the employment of at least one local. This is a Cameroonian scientist who's also been employed by the university to develop this laboratory and provide support to the public health degree course that they run there. Now, it turns out that there's also an Italian group working in Makeni. They had a laboratory based at the Holy Spirit Hospital, which is very close to us. And within that facility, they had a lot of reagents and equipment suitable for doing immunological analysis. So we've kind of teamed up together to form what we've referred to as the Makeni Biotech and Biomedical Research Platform, where we have a sort of combined capacity which enables us to do both molecular work and immunological work. The aim is that we will use this to train local staff, but also to facilitate research to be undertaken in Sierra Leone. And in fact, we've managed to convince at least one research group to move there, a company to move their research group there, and they've signed an agreement with the University of Makeni for 3 years that will provide up to 8 members of staff for the facility for 3 years, working in the area of infectious diseases and zoonoses. So with that, I'd just like to finish, and a huge number of people involved in this work. None of this would have been possible without funding from the Wellcome Trust and the belief that I could actually pull this off. I have to say that there were many a time where I didn't think it was going to happen, and I was very honest with the trust and felt that, you know, what if this sequencer falls off the back of the machine, back of the truck? What if it falls? What if it breaks? Anyhow, it all worked. I particularly like to thank Armando, who was one of my postdocs who helped me set up the sequencer at the start, and also Matt Cotton and Mi Fan from the Sanger Center. One of the biggest bottlenecks we had was getting the data back to the UK, and prior to these guys coming out and working with us, we were shipping back gigabytes of data every day. By having the bioinformaticians on site, we were able to ship back much smaller data files, and this really brought down the time frame involved. This is my favorite picture from my time in Sierra Leone. You can see we're all smiling despite sweating a lot, and I think, you know, what I would encourage anyone who hasn't done this sort of work to really get involved. This has been, without doubt, probably the most rewarding experience of my scientific career, and I hope that we will continue this sort of capacity building in the longer term. And with that, I'll finish. Thank you.
Well, a really fascinating end to the day. We're running a little bit late, but not so much that I thought, actually, we will take 1 or 2 just questions, because it is so interesting. I'm sure people are dying to know a bit more. So I'll take, you've asked 1 or 2 questions before. I'm going to take the guy at the back, and then one other from over to the right. We'll just take those 2, another one down there. If you could give the mic.
Ian, thanks very much. Heroic talk. And just a fantastic mobilization of your resources to set this up. Just first, a question about the atypical presentations, and are they unusual or infrequent, or are you seeing them more now that more attention is being paid to these?
Yeah, that's a difficult question to give my honest answer to. I think my gut feeling is that there will be, I guess you've seen the coverage of the case of the nurse in the UK. Without doubt, that will be happening in all the affected countries. The problem you have is that, and there may well be people dying of Ebola virus, this sort of reactivation, they will not become apparent to the response, because if somebody dies, what we do is we swab the mouth. And unless there's virus in the mouth, those patients are said to have died of an unrelated cause. I don't think this is, I mean, we've seen a few cases of what we think is sexual transmission. Again, it's difficult to really tie that down to sexual transmission. We've seen at least 1 case of transmission via breast milk, and we have another case where we've also got virus detected in breast milk. I don't think we're seeing a lot of it, but I wonder if we're really looking that hard, to be honest, whether the systems we have in place would detect this sort of reactivation. I don't think it would.
No, I agree, and that's linked to my second question, which was the sensitivity of the assays and the sequence-based assays. Many of the sequences that have been published have been from individuals with high levels of viremia. These have been plasma samples. But again, now we're in that secondary convalescent phase where we have persistence within the body. And the copy numbers are probably very, very limited and sequestered in places like the CNS and reproductive organs.
So our sequencing approach is an amplicon-based approach. So I would say the breast milk sample, the CT is around about 33, 34, which is very low. I don't know how that compares to the sorts of levels that they're seeing in these reactivated patients, because I don't have access to that data. But I think the sequencing is pretty sensitive. Of course, the diagnostic assay is more sensitive. The limit of detection is a CT of 40 there.
Okay, and the last question over here.
Ian, thank you very much for a very interesting and inspiring talk. I have a question with regard to the sequences you showed, and that you were able to discover transmission chains. And I wonder whether in terms of practical management, this information could be used to try to block such transmission chains.
Absolutely, and that's one of the biggest challenges I found was really making sure that the right people were getting the right information. For probably a period of 5 weeks, we thought we were contacting the right person, writing reports, sending them, and that information wasn't being deployed down to the people who really needed to know. So it wasn't until we got in contact with WHO that we were able to then make sure that the right people got the information in the right format. And that's exactly what it was used for. So many of the case studies that I haven't been able to tell you about were where you'd have individuals who just appear somewhere. We had a guy just appear on a roundabout in Freetown, dead. Nobody knew who he was. Nobody knew where he came from. And there was a concern that there was a transmission chain that was ongoing that people just didn't know of. It turns out that somehow he'd been infected from a chain of transmission that we already knew about. And in fact, he didn't transmit any further. We were also able to see that in some of these transmission chains that we identified, there was more than one virus in there. So there were multiple viruses circulating in a small area. But that information was provided to the CDC EPI teams, the WHO response teams, and we work very closely with them now.
Well done. Thank you very much, Ian. That's fantastic.